Good morning. So we'll be starting with a new chapter today, lines and angles. As I had told you, I'll be starting with triangles chapter, but until we know the basics of lines and angles, that is types of angles, different types of angles formed in a line, parallel line, etc., we cannot proceed to triangles chapter. So we'll finish lines and angles and then we'll proceed with triangles. So before actually we start with this lesson, there are some basic terms and definitions what you all should know about point, line, ray, line segment, etc. You all know this, but still let us understand and learn them once again. Point. A point is an exact location and it is represented by a fine dot which I have given it here. A line is a straight path. This is how we represent a line. That means it can extend to both the side. So there is no particular end in a line when we draw. Even it can increase, even it can extend here as well as here. So that it is limitless or endless, what we can say. Ray. A part of a line with one end point is called as a ray. That means if this is a ray, I can only extend B point to a wherever. It is limitless or endless where I can extend this, but it has one contact of point, or we can say it has a one end point and one limitless point. Line segment. A part of a line with two end points is called a line segment. That means a line segment is definite. So line segment, when I draw, I neither can extend it here, neither here, but a line segment is fixed. Collinear points. If three or more than 3 points lie on the same line, then they are called collinear points. Otherwise, they are called non-collinear points. Now look at this. PQR are lying on the same straight line, so we call them as a collinear points. Point PQR, where only QR is lying, of course, when we talk, 2 points will always lie on a line because we can draw a line only with 2 points, right? Third point is lying somewhere else. So PQR are non-collinear points. So this is about point, line, ray, line segment, collinear, non-collinear points. So give the heading as lines and angles, basic terms and definition, and you can start writing this. Now next we'll understand about angles and types of angles. Angle. A figure formed by two rays with same initial point is called an angle. So an angle always have two arms. So these are two arms of the angle with a common vertex point. And we read angle as wherever is a vertex that is represented as an angle, we read that as angle ABC. Complete angle. An angle whose measure is 360 degrees is called a complete angle. So now I have not written different types of angles. We all know that acute angle which measures, you know about acute angle, obtuse angle, right angle, right? So I have not mentioned anything about those type of angles, including reflex angle also. We'll next study about pair of angles. So that means when two angles are together, how do we derive the relation between them? Complementary angles. Two angles are said to be complementary if their sum is 90. So adjacent angles these are. So what you can say are these adjacent angles. So these are sharing the common, this one here. The sum is 90, that is angle 40 plus angle 50 is 90. Angle ABC and angle CBD is equal to 90. Two angles are said to be complementary if their sum is 90 degree. Similarly, supplementary angles, two angles are said to be supplementary if their sum is 180. Now angle AOC and angle BOC is equal to 180. Just measure 110 plus 70 will give you 180. From this we can say linear pair, that is when a ray stands on a straight line, then sum of the adjacent angle formed is supplementary. You have already studied this linear pair in standard 8. So wherever we come across a question where we have to find one unknown angle and it is a straight line, a ray standing on a straight line, then some of those angles formed are supplementary. That is what I have written. angle AOC plus angle BOC is equal to 180. We can straight away write reason here as linear pair. We are going to use these things in our exercises. So apart from this, that is a pair of angles, there are some relation between this pair of angles. So let's understand them. Before that, we'll see what are parallel lines and transversal. And the next is parallel lines. If two lines lie in the same plane and do not intersect when produced on either side, then such lines are said to be parallel to each other. So L is parallel to M. This is the symbol for parallel. Transversal lines. A straight line which cuts two or more straight lines at distinct point is called a transversal line. So a straight line which cuts two or more straight lines at distinct points. That means whenever we have a parallel line, a line which cuts that parallel line is called as a transversal. L is parallel to M, XY is called as the transversal. So we have some pair of angles with respect to when two lines intersect each other, or we can say when a parallel line is cut by a transversal, there are some angles formed, and what is the relation between those angles we'll be understanding by solving few theorems on them. So theorem 1 here. If two lines intersect, then vertically opposite angles are equal. We need to prove this. Now one thing you remember, children, this theorem 1 I have given in your book. This might be theorem 2, theorem 3. So theorem 1 does not state that this is the only theorem. Okay. So whenever you have to relate a theorem, you need to write that theorem in examples later. Like for example, we told that rays standing on a straight line, adjacent angles are supplementary. We just write AOB plus BOC is equal to 180. What do we write their reason as? We write them as linear pair. So here also, when you come across such vertically opposite angles are equal, you cannot say from theorem 1, right? You need to write the specific reason. So let's start. So prove that if two lines intersect, then vertically opposite angles are equal. Geometry. Your diagrams must always be on your right hand side, and theorem or whatever you prove should be on your left hand side. So these are the two straight lines which intersect at O. So AB and C. Given lines AB and CD intersect at O. This is given. What we have to prove? These things what you have to write in a theorem. To prove that vertically opposite angles are equal. So we just prove that one pair vertically opposite angle. That is, this angle is equal to this angle, or this angle is equal to this angle. So when two lines cut each other, they intersect each other. When two lines intersect, vertically opposite angles are equal. Suppose if this is 30 degree, you can say this is also 30. It has to be, because they are vertically opposite angles. Okay. So to prove, I'll choose one pair. Angle AOC is equal to angle BOD. Angle AOC is equal to angle BOD. This is what we have proved. Okay. We'll start with it. Proof. Now, which angle you have chosen? With respect to that, write a linear pair. So now I will choose this and this as a linear pair. I will write angle AOC plus angle BOC is equal to 180. Linear pair. Okay. Equation 1. Next, now this and this is equal, that is, this and this when you add it is 180, linear pair. Equation 1, choose another linear pair such that it is a part of the same linear pair and the another angle what you have to prove. Don't take this and this as linear pair. You have chosen this and this, make sure the next linear pair is again this and this only. So next I can say angle BOC plus angle BOD is equal to 180. Equation 2, reason linear pair. Okay, both are equal to 180. That means actually there's another chapter called Introduction to Euclid's Geometry, where we study about axioms and postulates. So what are these axioms? There are some elementary statements. Now what do you mean by this? How do I correlate an axiom here? Now this is also equal to 180, this is also equal to 180. So can I tell these two are also equal to each other? That means, for example, if I say this is angle 60 degree, this is angle A, and this is angle B. Okay, or this is also 60 degree if I tell. Now both are 60 degree equal. So if I tell this is equation 1, equation 2, equation 3. If I say angle or equation 2 is equal to equation 3, that means if equation 2 is equal to equation 3, can I tell equation 1 is also equal to equation 3? Why? Because these both are equal, they are 60. When this is also equal, it is again equal. The thing is, things equal to same thing are equal to one another. Things which are equal to same thing, things equal to same thing are equal to one another. That is actually called as axiom 1. So you can either write it as axiom 1 or statement. So what I will write here is, from equation 1 and 2, angle AOC plus angle BOC is equal to angle BOC plus angle BOD. Reason, things equal to same thing are equal to one another, which is axiom 1. So these both are equal. BOC is same. I'll cancel. What did I get? Angle AOC is equal to angle BOD. Therefore, vertically opposite angles are equal. This is the small simple theorem, right? Before I move to the next theorem, that is with respect to parallel line and transversal, you need to identify when a parallel line is cut by a transversal, what are the different types of angles formed in them. Only if you understand, we can proceed with the theorem easily. So let's understand, when a parallel line is cut by a transversal, what different pair of angles are formed and why are they equal. So that will be our next theorem actually, but before that let's understand the types of angles formed. You need to learn to identify these angles. So there also vertically opposite angles are also formed. Let's understand. So assume that this is a parallel line cut by a transversal. So AB is parallel to CD, L and M is the transversal, cutting at X and cutting at two distinct points. Now what I will do is, to make it very simple, I'll just name the angles as 1, 2, 3, 4. 1, 2, or don't want this, only 1, 2, 3, 4 will name. 1, 2, 3, 4, 5, 6, 7, 8. Let us see how many different pairs of angles are formed when a parallel line is cut by a transversal. First of all, let us name all vertically opposite angles. Okay, how many pairs are formed? Let us see. So when I see here, when I say angle 3, angle 1 is equal to angle 3, angle 1 is equal to angle 3. Next, angle 2 is equal to angle 4. Angle 2 is equal to angle 4. Next, angle 5 is equal to angle 7. And next, angle 6 is equal to angle 8. How many pairs of vertically opposite angles are formed? There are 4 pairs of vertically opposite angles formed when a parallel line is cut by a transversal. Yes, you have to do this. Nothing, no heading, nothing here. After the theorem, you can just draw this and start writing number of pairs of angles formed. Okay. Now let's identify alternate angles. They are called as interior alternate angles. So this is alternate, these two are equal alternate angles, and this is another pair of alternate angle. Okay, that means how many pairs? Only two pairs are formed. I'll first try, I'll explain them later. Angle 3 is equal to angle 5, and second one, angle 4 is equal to angle 6. Only two pairs are formed. What is the formation of our alternate angles? Interior, see here children, it is always the Z formation. These are alternate angles, or see, these are alternate angles. Okay, alternate angles are always formed in the Z. Otherwise, if I write alphabet I, alternate angles, right? So this is equal to this and this is equal to this. This is how alternate angles are formed. They are always formed between the Z formation, what you can tell. Inside the curve, what angle is formed, those are alternate angles. Then which are corresponding angles? Shall I write corresponding angles here? Corresponding angles. Let us see which are all corresponding angles here. So I will rub this now, otherwise it leads to a confusion, right? What you can do is you can have two different figures. Once for alternate angle you can redraw the figure once again and mark the angles for corresponding angles. I am repeating. After you finish marking for alternate angles, or do one thing, you can have this figure for vertically opposite angle once, alternate angle once, corresponding angle once, that it is easy for you in marking. It looks very clearly and visible. Have the figures as and when you write this once again. Corresponding angles, I must mark. Angle 2 is equal to angle 6. That means angle 1 is equal to angle 5. Okay. Next, angle 3 is equal to angle 7. Then angle 4 is equal to angle 8. How many pair? So let us write. First one, angle 2 is equal to angle 6. Second one, angle 1 is equal to angle 5. Third one, angle 3 is equal to angle 7. Fourth one, angle 4 is equal to angle 8. What are the types of corresponding angles? Now see, this is a pair of line, and if you cut a transversal here, this is corresponding to this always. Like this the corresponding comes. Or, of course, this is corresponding to this. If I have a parallel line like this and this is a transversal, children, this is corresponding to this. So that is how different combinations I am just showing you in corresponding angles. That is what you need to identify. Now, do you think I have just drawn these figures for my sake or myself or something? It is your duty to make, draw, understand what are the different formations it could be for corresponding or alternate angles. How many pairs of corresponding angles are formed? 4 pairs of corresponding angles are formed. And that is fixed. You can't tell I got 6th pair or 7th pair. These are the fixed pair when a parallel line is cut by a transversal. Okay. Next, let us see next. So please have a different figure for different types of angles formed here. I am going to rub this. If you want, you can draw it for your reference. Left to you. Let us see what is the next pair. Interior angles. What is the relation interior angles? So, of course, now linear pair I will not write here. Look at the linear pair. 1 plus 4 is 180. 1 plus 2 is 180. 4 plus 3 is 180. 3 plus 2 is 180. Linear pair. I will not write that. 5 plus 8 is 180. 5 plus 6 is 180. 8 plus 7 is 180. 7 plus 6 is 180. Linear pair. These are all formation of linear pair which you should know. I am not writing. Interior angles I will write. These are called as co-interior angles. Interior angles are always found between the parallel lines, I mean in between the parallel lines where the transversal is cut. That means these are in between, inside the parallel lines where we cut the transversal. These are co-interior angles. So we'll write, that is first pair, angle 3 plus angle 6 is equal to 180. Not linear pair, interior angles. We have a reason also to write. I'll tell you what. Angle 4 plus angle 5 is equal to 180. When you have to write this relation, what reason you will write for that is co-interior angles are supplementary. When a parallel line is cut by a transversal, co-interior angles which are formed are supplementary. So these are the different things where we make use in our numericals or sums or theorems or riders what we solve, which you all should know it better. Based on this, we have different theorems. So children, so before we start, we will be starting with the theorems in tomorrow's session. There are theorems on when a parallel line is cut by a transversal. We need to prove that pair of alternate angles are equal, corresponding angles are equal, co-interior angles are supplementary. These are theorems. We also need to prove the converse of theorem. What do you mean by converse? If two lines is cut by a transversal such that pair of alternate angles are equal, then we have to prove that the given two lines are parallel, right? This is something converse, which we will be doing it in tomorrow's session. But before we do, you need to practice this because you need to identify the types of alternate angles. See children, in several sums, alternate angles can also come like this. Now which are the pair of alternate angle? Remember Z formation, right? This angle is equal to this alternate. This angle is equal to this. Corresponding angles are only formed when you have like when they are lying like this, something. Alternate angles are usually formed when we have two intersecting lines and parallel lines. You will understand as and when we proceed. Main thing is you need to identify these angles. Once you learn the identification, it becomes very easy. So your homework is today, try to draw different set of parallel line cut by a transversal and try to identify vertically opposite angles, alternate angles, co-interior angles and corresponding angles. With this I end my class. Any doubt in today's session, you can call on the same day of the video set. Thank you.